Okay, class, we're going to start today with how do you add and subtract polynomials. All right, so at this point you should be comfortable with what a polynomial is, how to deal with it, what they look like. So we'll just get started. If you look at this first box here, what I want you to do, if you need to pause the video, you can. What I need you to do is go ahead in your notes, write a couple things that you may know about this problem or have questions about this problem. All right, so if you want to pause it now, go ahead and do that. And we are going to move on to the second portion. All right, as we get started, the main thing that we want to be comfortable with when we're adding and subtracting polynomials, you can find here. The main skill that you need to add polynomials is combining like terms, which I call CLT. So combining like terms, CLT, pretty straightforward. Okay, this is a skill that you've learned from IM1, and some of you may have learned it from middle school. But before I could get into CLT, we got to be comfortable with another step that has to take place before we can do CLT. And that step that I'm referring to is getting rid of parentheses. We do not like parentheses. So our goal before we can do CLT is get rid of these parentheses. Anytime you see a parentheses, we want them to go away. If you do not have parentheses, then you don't have to worry about this first step. So in essence, that first step should be right in here, okay, above combining like terms for polynomials. So when we add and subtract polynomials, just to make sure that we're on the same page, the first thing we really want to do is get rid of parentheses. Okay? In order to do that, you've done this before, you want to use the distributive property. Okay? And we'll get into more detail about what the distributive property is and go from there. The next step we want to do when we're adding and subtracting polynomials is combine like terms. And that's kind of what you see in the bullet here. All right? And last but not least, the proper way to display your answer is we want to rearrange our answer in highest exponent down to the lowest exponent. Okay? And that's a proper way you want to display your answer. So if you notice, if we go back up here, we have two ways we can do adding and subtracting. I know right now we're just working on adding, but it works exactly the same for subtracting, as you'll see in a little bit. But there's two ways. We could do vertical format or horizontal. I personally prefer horizontal format just because I believe it's faster. Especially when you're comfortable with combining like terms, the horizontal format is going to be the way to go. I know some students prefer the vertical format, which is okay. It takes a lot more space. It's a little more organized. You can see what's going on. But like I said, I prefer the horizontal. And if you're comfortable with it, that's the one I would shoot for. So I'm going to show you both. So we have this example here where we're going to add 5x to the third plus 3x to the second minus 2x minus 1, and we're adding it to 4x to the third minus x plus 2. Okay? So the vertical format is a very kind of straightforward format. If you notice, in the vertical format, all we essentially did was rewrite our first polynomial here. Okay, did not do anything special there. And what we did for the adding of the second polynomial, 4x to the third minus x plus 2, we simply kind of matched them up with the same variable to the same power. So 4x to the third went under 5x to the third because they both have x to the third, x to the third. Now, if you look, the next monomial here, or the next term, is negative x, which actually has a little power of 1. So he is going to line up with the powers of 1, or the guy with just the x. So he goes under the negative 2x, and that's where we find our negative x goes to the negative, under the negative 2x. And then our constant, positive 2, gets lined up with the other constant. And once we have organized this in such a way, we simply just do the combining like terms. We either add or subtract vertically depending on their sign. So if we completed this problem, it would essentially look like this. We would take 5 plus 4, so positive 5, positive 4, that would give me 9. And because we organized it, we don't have to worry about are they like terms. We already organized it, so we just bring down the x to the third. We go to the next monomial, 3x to the second. There's no term here. So basically, essentially, there's like a 0 here. So because there's nothing to add or subtract to this, we just essentially just bring this down, including whatever sign we have. So it turns into positive 3x squared. And we just brought that down. And then we continue this throughout the rest of the problem. Common mistakes on these combining like terms are just the signs, adding and subtracting positive and negative numbers. So if you look here, we have a negative 2, and negative x is really just a negative 1x. So negative 2 with negative 1, that's going to give me a negative 3x. And then we move on to the constants, negative 1 and positive 2. We're left with a positive 1. Okay? And that is the vertical format. If we look back at our steps, the way the problem was written out, and eventually it will change, but we really had no parentheses, so we didn't have to use a distributive property. The vertical format was our CLT. We combine like terms. And then we want to rearrange it in the highest exponent to the lowest. If you look, we have x to the third, that's the highest power, then the next highest power, and so on. So this is already rearranged, therefore we did steps 1 through 3. Okay, and that's vertical format. If we go on to the horizontal format, it's essentially the same thing, except we are not organizing it kind of like we did here. Okay, all we're going to do this is more of a mental math of combining like terms. So just like on the steps over here, we want to make sure in step 1 that we get rid of the parentheses. So to get rid of the parentheses, we want to make sure there is nothing in this area here that we need to distribute in. Okay, since there's not a number there, well, there's nothing to distribute, so that means we can essentially rewrite this guy without parentheses, which I will do now. So the parentheses in the first polynomial, we don't need them because there's nothing to distribute. Now we look at the second set of parentheses. Again, we want to look in this region. We have a number other than 1. Again, when there's no number here, it's really just a 1. So since we have positive 1, we really do not have to distribute any. There's nothing to distribute here. So again, we can essentially get rid of our parentheses here. So I'm going to rewrite these guys with their sign. So right, if you look here, this is a positive 4 minus x plus 2. Okay, so now this is the horizontal format. Step 1 is done. We got rid of the parentheses by checking for distributive property, which we had none. And now we're going to just combine like terms. What I like to do is go from one guy to another. So I'm looking for anything. I'm looking for anything with an x to the third. So we have 5x to the third, and I'm just going down the line and looking for x to the thirds. And if you notice, I have 4x to the third. And I continue going down the line, no other x to the thirds. And now we're simply going to combine the coefficients, the numbers in front of the variable. So I have positive 5, positive 4. That will give me a positive 9. And I write it out in front. So 9, and then we bring down the x to the third. What I like to do is cross these guys out just to keep things organized once I use them. Once we did the first term, we then move on to the next term. We're looking for x to the seconds. So as I go down the line, I'm looking for x to the second. So we have this guy, and we do not have any other x to the seconds. So I'm simply just going to rewrite this guy down here with his appropriate sign. So it's positive 3x squared. Again, crossing them out when you use them, and then we continue on to the next guy. We're looking for x's. Okay, so now we look here. We have an x and another x. So I have negative 2x and a negative 1. Remember, there's an imaginary 1 here. So negative 2 and negative 1, when you put those guys together, that's going to give me negative 3. And bring down the x, cross them out because we're done, and we just continue on until we're took care of everybody. So now I have the constant negative 1 and the constant positive 2, and when we combine those, again, common mistakes are messing up with adding, subtracting positive and negative. So positive 2, negative 1, that's going to be positive 1. And there you go. This would be our final answer, and this is how you do horizontal format. Okay guys, go ahead and I want you to try example A and B. So if you could pause the video, go ahead and do those on your notes. Remember, follow these steps. Step 1, get rid of parentheses, combine like terms, whether you're using vertical or horizontal format, and then when it's all said and done, rearrange your answer into the highest exponent term first down to the lowest. Alright, pause the video and we will work these out in a few. Okay, so like I said, I prefer doing horizontal method. So the first thing I want to do is make sure I don't have anything to distribute to get rid of the parentheses. So if you look, there's nothing here to distribute in, and there's nothing here but a positive 1 to distribute in. So essentially there's nothing to distribute, so I'm going to rewrite these guys without their parentheses. All right, so the parentheses are gone. Our next step is combining like terms. So this is where all the common mistakes happen. I'm going to go ahead and start combining like terms. All right. So we're going to go ahead and combine like terms. We're going to do x to the 4s, any x to the 4s, and the answer is no. So I'm just going to write down x to the 4, 4x to the 4, sorry. Gone. Cross it out just to keep things organized. The next thing I'm looking for is x to the 3rds. And we do have another x to the 3rd here. So again, there's a positive 1x to the 3rd. There's a positive 1x to the 3rd. Don't forget those are positive 1. So positive 1 and positive 1. That's going to give me positive 2x to the 3rd. And I cross them out because I'm done with them. Then we move on, 2x to the 2nd. And any other x to the 2nds, which I do not have, so I simply just write that guy down. Bring them down, 2x to the 2nd. Cross them out because I'm done. And then we move on to any x's. So I have negative 1x, and I have positive 3x, negative 1x, and positive 3x. That's going to give me positive 2x. Okay, cross them out, and you'll notice the last thing we have is a constant of negative 1, which means we just bring that guy down. Okay, so step 2 is done. We combine like terms. Essentially, the math is all done. What we just have to make sure to do it properly is make sure the highest power goes first, then followed by all the next lowest powers all the way down. So if you look, this guy and this guy are not in the proper order. There's a power of, sorry, my mistake. They are in the proper order. So this guy is already in the proper order because it's power of 4, power of 3, power of 2, power of 1, and then the constant. So we are all set here. And this would be your final answer. All right. Okay, example B is a little more challenging, and I'll explain why as we get through it. But first of all, the steps to stay the same. We're going to get rid of parentheses by distributed property. And again, you should notice that there's nothing to distribute in front, so we simply can write the first polynomial without the parentheses. So we're going to go negative y(x to the 3rd) plus 2y. Moving on to the second polynomial, there's nothing to distribute here, so therefore I can just rewrite it with parentheses. Very important. Sometimes students get confused. We have a positive here, but we have a negative here. The sign we want to put here is the sign that goes with our first term here, which is negative 4y(x to the 3rd). So this is the sign we want to keep. When we do subtraction, it'll change a little bit, but for now you want this negative 4y(x to the 3rd) to be written down. You don't want to do plus negative 4y(x to the 3rd). So it's negative 4y(x to the 3rd) and plus x squared plus 5y. Okay, so we got rid of the parentheses, step 1. Step 2, we're going to combine like terms. And here's what you kind of have to, here's the difficult part, or the more challenging part here. If you look at this first term here, it actually is a first term with two variables. We have a y and we have an x to the 3rd. So when we're looking for like terms, we need to have a y with the x to the 3rd. So if you go to this term, it only has a y. It needs to have a y and an x to the 3rd. So the like term for this guy is actually going to be this term, this monomial here. this has a y and an x to the third. So once the variables and exponents are matched up, we simply just look at the coefficients, the number in front. So in this case, we have a -1 and a -4. So -1 and a -4 come together and they give you a -5yx to the third. And we cross them out. Okay, those were like terms. And we continue this process just like we did in example A. So we're looking for just the y now. And we have a y here. So +2 and +5. That gives me +7y. Wrong color again. +7y. Cross them out, and then if you look, the last term we have is actually x to the second. There's nothing to combine with there, so we're just going to bring him down. That's going to be positive x to the second. So we're done with the CLT. And again, this one's a little more challenging. So in step 3, when we rearrange, you simply just want to put the highest powered first. So if you look, this has the highest power. It's power of 3. This is a power of 1. This guy's a power of 2. So x to the second has to come second. So I'm going to rewrite this in the proper order. So it's -5y x to the third plus x to the second plus 7y. And now step 3 is done, and this would be our final answer. Okay guys, now we're going to go ahead and start subtracting polynomials. And subtracting polynomials is essentially the same steps as we had before for adding polynomials. It's the same thing. So if you look on the left here, I just kind of copy and paste the same steps, and we're going to do the same steps here. Like in the first slide, you can still use vertical or horizontal format. All the examples I'm going to do today on this slide are going to be used with horizontal format. So if you still follow these steps, step 1, get rid of parentheses using the distributive property. Then you're going to combine like terms and rearrange your answer. You basically do the same process for these type of problems, which we would call subtraction just because of the negative sign, but it's essentially the same. So I'm going to go through this first example. Again, common mistakes here is students just mess up with the signs. So go ahead and we'll follow along. So first step we want to do here is get rid of parentheses. So if you look at our problem here, we want to look in this area if there's anything to distribute besides a +1. And since there's nothing here, we can then just rewrite this guy without parentheses. So that's what I'm going to do for the first polynomial. So we're going to have -3y to the fourth minus y to the second plus y minus 1. All right, and then we're going to go ahead and look at the second set of parentheses. And if you notice, there should be a 1 here. Remember, when there's nothing there, there's really a 1, and actually it's going to be a -1. So I'm going to write in a -1 here. Okay, because it's a -1, we can't just get rid of these parentheses. We actually got to do the distributive property for this set of parentheses to get rid of them. So I'm going to take this -1, because it's negative, I'm going to multiply it with all the terms inside parentheses. So it's going to look something like this. So -1 times -2 2. So negative 1 times negative 2, that's going to give me a positive 2y to the fourth. And then we go negative 1 times positive y, and that's going to give me negative y. And negative 1 times positive 1, that gives me negative 1. So if you notice, essentially, when we distribute a negative sign into the second polynomial, we're essentially just changing the signs. Okay? So now, if we look at our new polynomial, we are now, step 1 is done because there is no more parentheses, and then we go and continue what we did in the previous slide. We are going to combine like terms. So let's do that. So I'm looking for anything with a y to the fourth. So if you look, y to the fourth, y to the fourth, and then I'm going to combine them. So negative 3, positive 2, that's going to give me negative 1 y to the fourth. And we're just going to write it as negative y to the fourth, which means negative 1 y to the fourth. Okay, cross them out because we are done with that. And then we move on to the next term, which is negative 1y to the second. So negative 1y to the second, and the other y's to the second power. And the answer is no, so we're just going to drop that guy down. Negative y to the second, cross him out. And then we move on to the next term, just like we did before, positive 1y, and we have a negative 1y. So positive 1 and negative 1, that actually turns into 0y, which basically they cross each other out. It turns into 0y, so we don't write anything for that. And then we have the last but not least, the constants. We have negative 1 and negative 1, and that's going to give me minus 2 or negative 2 when we combine those terms. Done and done. So step 2 is done, and now we just look at our exponents. And our exponents, we just want to make sure we have power of 4, power of 2, and a constant. They are in the correct order. This would be my final answer for this example. So as you can see, we essentially are doing the same process. We just have to be careful. Because of this negative sign, we want to distribute it in as if it's a negative 1 to get rid of the parentheses. Once you do that, everything kind of goes the same as we did in the first slide. So if you go ahead and do C and D, pause the video, work them out, and then when you're ready and have your answers, I will work them out for you. So first step, we're going to get rid of parentheses. This first guy in example C, we do not have to distribute, so I'm simply just going to rewrite again. So we have negative 2z to the third minus 18y z plus 12y. Here we're going to have to distribute this negative, or remember it's really a negative 1. So there's a negative 1 here. I'm going to distribute it in, and if I do that I get negative 11yz minus, actually sorry, negative 1 times negative 5 is positive 5y. Once we have distributed and our parentheses are gone, we can begin combining like terms. So z to the third, we're looking for another z to the third. We do not have that, so I'm just going to go ahead and copy negative 2z to the third, cross them out, and then we are looking for this guy, which is y with a z. Y with a z. We have it here. Combine those like terms, so negative 18 and negative 11. That's going to give us a negative 29y to the z. And then cross them out because we are done with them. And we move on to the next term. And we have 12y. And we have 5y. They both have y, so we're going to combine those. 12, positive 12 and positive 5. That gives me positive 17y. Oops. I want red. So positive 17y. Gone. Gone. And we do have the correct order. So step 3, we do not have to rearrange. This will be our final answer. All right, I'm going to go a little faster on example D. I think you're starting, hopefully you're getting the hang of this and it's not too difficult. So first step, get rid of the parentheses. The first set, we don't have to distribute, so I'm going to rewrite. And then I'm going to distribute this negative 1. And we end up with positive x to the third minus y minus x. And then we combine like terms. Step 2, combine like terms. And we have x to the third, x to the third, negative 1x to the third, and positive 1x to the third. When I combine those, they actually cancel each other out. They turn into 0x to the third, which is nothing. We move on to the next term, y to the second. So we're looking y with the power of 2. We only have this guy, so we just bring him down. So we have y to the second. Cross him out because we are done with him. Move on to the next term, which is just y, and we have y here, so it's positive 1 and negative 1. They will then cross each other out again. They turn into 0y, or they disappear. And we move on to the next term, negative x and negative x. That gives me negative 1 and negative 1. That's going to give me a negative 2x. And it is already in the correct order. So this would be our final answer. So essentially, you do the same steps as adding and subtracting as you did. You do the same steps for subtraction as you do addition. Like I said, the common mistakes that we always get, or I always see, is students struggle with the signs, or they go too quick with the signs and mess up or add or subtract incorrectly. All right, go ahead and fill out the following on the rest of the slide. Put this information on your note, so you're gonna, in your own words, go ahead and answer that. And I want you to work out and answer the question here in your notes. So if you want to pause the video to see if you get the correct answer for this guy here, go ahead and do that now. I'm going to answer this question for you now. So in this example, this is what you should have done. We get rid of the parentheses. There's no distribution required. We want to check, once we're all said and done working this out, we want to check if it's equivalent or the same as this guy up here. So let's work this out and see if they are the same. So as you can see, I've already got rid of the parentheses. There was nothing to distribute here, so I just simply got rid of the parentheses, keeping the negative sign, not the positive sign, the negative sign with the 3. And now we're going to go ahead and combine like terms. So 5x to the third, there is no like term here, so I'm going to write him down, 5x to the third, cross him out. Move on to positive 7. He is a like term with positive 2. They are constants. So positive 2 and positive 7, that gives me positive 9. Cross them out. And then we bring this last term down, negative 3x squared. We just bring it down. There's nothing else to combine with. Okay, and now we are going to rearrange. So 5x to the third goes first because it's the highest power, minus 3x to the second, and then positive 9. And now we want to check, is this equal to this? And the answer is no. Okay, so here we would say no, and this work here is actually our proof. All right. Okay, we're going to go ahead and move on to the next slide. And on this next slide, this is just going to be a kind of a different style of problem. So I want you to work it out, put it in your notes, and so pause the video and we will go ahead and do this. But please try to work it out before you go on and look at the answer. On second thought, we'll just do this in class.